spark your curiosity in the world of design and the important role it plays in our society. We hope that through these workshops, we can inspire students to use design as a tool to collaborate and generate positive change. For those of you who have missed our previous workshops, you can visit the WHSAD YouTube channel, where we have session 1, The Future We Choose by Joseph Brancato. Session number 2, which is a day in the life of a designer at Gensler. Here you'll get to meet some of the talented staff members at Gensler, such as Ariel Levy, Shason Van Lang, and Liz Russell, interior designer, architectural designers, and strategists. Today's session is called Design Resilience, and I will now pass it over to our program coordinator, Anne Sophie Hall, who will be introducing our guest speakers. Welcome, Anne Sophie.
Thank you so much, Mr. Rodriguez. Oops, I can hear an echo for some reason.
Yep.
I'm not sure. I don't think it's on. Okay, all good, if you can hear me. Thank you so much, Mr. Rodriguez. This is a great introduction, and I'd like to, we're very excited, as always. It's our third session, as you were saying, and I'd like to thank you, number one, for your partnership and for your collaboration when we are organizing those sessions. We couldn't do it without your collaboration. And then obviously thank you to the school and also to the students who have been very active in their interests, and we were very thrilled to hear from them at the very beginning when we started this program back in November. And the first thing we had done, if you remember correctly, was a little bit of a poll to see what really what was on your mind, what was on the mind of the students, what they wanted to hear about next. So we have a lot of ideas thanks to that in the planning. But one theme that came back, if I remember, 3 to 5 times, was sustainability. So today, hence the topic that we've chosen to really articulate our presentation around, which is a little broader than design resilience, than sustainability. We're calling it design resilience, and our first speaker, Lina, will explain to you the commitment that Gensler has made towards meeting design resilience and certain climate change goals. So we will start with that. And then, typically I take great pleasure at reading the presenters' bios. Why is that? Is because I also think that, it's always fascinating for me to read it, but also I hope for you, all the students, to really understand that, all the people who are working and designers in general, but all our designers at Gensler really have come to design and choose design from, different paths to get there, but also different reasons and different passions. So I noticed that Mr. Rodriguez had put the bios of each of the speakers in the invitation for the event today. So I won't take too much time. I won't take any time to read them, but I would really invite you to read those biographies, because they really do tell you that there's many ways, many paths, and many reasons to choose design as a profession. But today I'd like to, so we will hear from Lina, holistically why, what Gensler has committed to when it comes to design resilience and climate change goals in particular, and what means design resilience. And then we've chosen 2 projects to exemplify, what we're trying to, do when we commit to design resilience. So the first project is going to be presented by Geoffrey Diamond, and it's an architectural project. It's a full ground-up building, and we've chosen this project because it kind of illustrates the fact that design resilience can be very complex and very kind of painstaking and have really ambitious goals and be expensive and all that stuff. But we wanted to show you that there's also some very basic ways to start thinking about a project, an architectural project or design, in a way that really integrates design resilience in some very, very what we call low-tech ways. And Geoffrey will walk you through that. And then another project, the next project, the second project, will be presented by Tom Brock. And today, and it's an interior design project, the Delos headquarters interior design, for which we also provided digital experience design. But I would like to introduce also our client for this project, who is joining us today, and we're really thrilled to have her with us. And Anna Obratowska is, and I hope I'm saying the name correctly, was our client, is with Delos, and Delos is really, you know, kind of the world's catalyst for enhanced health and well-being in the environment in which we, you know, we all live and work and play. And they really take, you know, they took the design of their headquarters really seriously, and kind of showcasing and using it almost as a mock-up to, you know, to see what can be done when you take such a serious stand on, you know, enhancing health and well-being. So with that, I'm going to pass it on to Lina, and I will also ask, and Anna, our client, will be really talking to you about Delos's mission, because they are quite exemplary when it comes to, you know, again, really taking a stand and exemplifying those great the great mission. So Lina, without further ado, I want to pass it on to you, and go ahead.
Good morning, everybody. Let me just make sure.
Actually, Lina, I'm sorry, I'm going to interrupt you.
Sure.
I wanted to give a big shout out to the students last time. The three speakers who presented a month ago were very pleased and delighted to have had so many questions after the presentation, but not only so many questions, but really to engage in a conversation with the students. So we definitely encourage you to keep your questions in mind, and the presenters will be, I'm sure, as delighted as last time to engage in a conversation and answer the questions. So a big shout out to the students for their participation. Thank you. To you, Lina.
All right, can everyone see my screen okay?
Yes.
Great. All right. Thank you so much for letting us join you today to talk about design resiliency. Over the past year, we have been working towards strengthening our strategies to tackle climate change issues. Through design resiliency, we define design resiliency as the ability to anticipate, prepare for, and respond to challenges and threats of climate change. As designers, we aspire to create cities, building communities that will be able to absorb the risks, adapt, recover, and return to a functional state. Over the past half-century, the Earth's surface has continuously been exposed to increasingly warmer temperatures, as this is due to greenhouse gas emissions. These emissions are produced when fossil fuels are burnt and in turn deplete our ozone layer, that protective cap that protects the planet Earth from harsh radiations. The most commonly known culprits are transportation at 28%, industry and manufacturing at 22%, electricity at 26%. However, based on a report by the United Nations Environment Program, in 2019, the building sector accounted for a whopping 38% of CO2 emissions. This proves that climate crisis can't be addressed without transforming the way we construct our built environment. Our actions, which have led to global warming, have progressively created hazardous climatic conditions. This includes droughts, sea level rising, storms, and increased precipitation, and I think we are all well aware of these elements. Inherently, these climatic calamities have had a significant and very negative impact on planet Earth. We are now seeing an increase in global migration as climate refugees seek shelter and safety. Climate change threatens our public health, from water access to heat and respiratory illnesses. Furthermore, we're seeing the destruction and endangerment of wildlife. Confronted with all these challenges, we're implored to do more and do better. So with that in mind, this is why in the fall of 2019, we announced the Gensler Cities Climate, which Anne-Sophie had addressed, the GC3, where we challenge ourselves and the rest of the design and building industry to become carbon neutral by the year 2030. This initiative aligns with the Paris Climate Agreement, which is an international agreement among nearly 200 nations to combat climate change. Participants are committed to keep global warming below 2 degrees Celsius and above pre-industrial levels, and if possible, below 1.5 degrees. We're setting a simple but audacious goal: the elimination of all greenhouse gases associated with our work by achieving carbon neutrality. This means offsetting the carbon emissions related to our work. And so I like to think of architecture as a profession where we wear multiple hats: that of problem solvers, experimenters, inventors, and artists. I believe that climate change demands us to think in that way. The first thing to do is to transform the way we perceive the life cycle of a project and building. So it means instead of looking at it in a linear timeline, let's look at it in a cyclical way. And in doing so, we can look at this chart and see that the highest levels of CO2 emissions occur before and during a project's construction. This is because the sourcing of material, the transportation of the material, the manufacturing of the material, and the assembly and construction and installation of the building materials accounts for a majority of the building's carbon footprint. What we want to do with GC3 is implement strategies that will offset that throughout the remaining life cycle of the project, which is shown here as the green swath. And then towards the end, when we start thinking about, the end of the use of the building, the disposal of the materials, we have to think about, can this site and building be reused? Can these materials be recycled and be reused? And we're going to take it a step further and say, let's focus on this area where there's that high peak of CO2 emissions and see how we can do things to reduce that. Which brings us to this chart. And number one of the primary things is the location of buildings and the sites. When we deforest or clear land, we can harm its ability to absorb carbon emissions. We also destroy existing and long-standing ecosystems. So whenever possible, it's preferable to build on sites that have been used before. Another element is material sourcing, the production of it, and the transportation, as I mentioned before. The products we use in buildings are created by sourcing materials and refining them through industrial processes, which produce emissions and toxic waste. Then, more emissions are produced when they're transported to the construction site and assembled in place. The impact of this process is called embodied energy, and the resulting emissions are referred to as embodied carbon. Embodied energy also can include the energy related to the demolishing of buildings at the end of their useful lives. And as we progress throughout the design development of the project, there are certain principles that we want to employ. Conventional wisdom suggests that energy efficiency is addressed primarily by systems used in buildings, for example, by choosing better mechanical and electrical equipment. However, studies show that up to 90% of the impact of a project is determined by the earliest design decisions. Better performance is first and foremost a design strategy. So here are some basic considerations. Number one, build only when you need to. Research shows that existing buildings can be twice as efficient with resources because the energy to create the structure has already been spent. In fact, it can take up to 80 years for a new, reasonably energy efficient building to make up for that impact of having been built in the first place. Upcycle is a project in Austin designed by Gensler, which converted an abandoned warehouse into a creative office space, preserving 95% of the existing materials. And this means this was a huge savings in the embodied carbon. The second principle is build only as much as you need. Right-sizing the space we design can save significant amounts of energy, materials, and money by avoiding overbuilding. Every square foot counts. Here you see the Queen's Health Center, which houses a new form of healthcare delivery that brings doctors to the patients, rather than the other way around. Therefore, requiring far less space. The team started with a program of 200,000 square feet, and by working closely with the client to improve functionality and efficiency, we were able to reduce this by 80,000 square feet. That's a 60% savings. We found that using an efficient area per person can have a dramatic benefits. If every office building in America shrank by just 10%, emissions would decline by the equivalent of taking 7 million cars off the road. The third principle, and I'm sure you're all familiar with, is working with the sun. In a couple of hours, the amount of energy reaching the Earth's surface from the sun exceeds the total energy used by people in the whole year. By designing spaces to work with the sun, we can noticeably reduce our reliance on artificial heating and lighting. Here is a sun diagram. So facing a building primarily north and south can cut energy consumption by up to 20%. In many cases, we can provide better daylight simply by locating open and common spaces along the perimeter of a building. Facade systems are one of the main features correlated with solar conditions, and there are different ways to enhance shading and articulate them as part of the facade system. We can employ vertical fins, which are more efficient at shading low angles from entering the east and west facing facades. Horizontal fins or shading, which is right here in the middle, is effective at shading high angles from the sun entering in the north and south facing facades. And then we have the egg crate and decorative schemes that are a combination of both. So here in this page, I wanted to draw your attention to creative ways in which sun shading has been employed. And these are 3 projects, including our Shaw Crate Center in Cartersville, Georgia. Another principle is using less stuff. Within a given amount of space, we can also reduce the amount of material we use. In fitting out a space, we can dramatically reduce the materials and products needed by building fewer walls and surfaces. Additionally, the EPA recognizes open work plans as a standard strategy for saving energy because even without reducing the area of a building, fewer partitions make it easier to distribute artificial light and mechanical air at lower quantities with less equipment. Open space also allows natural light and outside air to spread more easily, lowering dependence on electrical systems. Many smart office buildings require no artificial lighting at all during the day, and this simply cannot be achieved with too many walls. Studies show that energy efficiency in open space can be over 2 times greater than individual offices. A 5th principle is using appropriate materials. Many materials and products take enormous amounts of energy to produce. For example, concrete is the most widely used man-made material, second only to water as the most consumed resource. The cement used to make concrete is the source of about 8% of the world's CO2 emissions. We can improve the climate impact of materials and products by using materials that have low embodied energy and high recycled content. And I really like this quote here, said by Mitchell Joaquim, who's an architect and an urban designer and teaches at NYU. He says, "Eventually, the future city will make no distinction between waste and supply," which leads me to present these samples of materials, where, for example, let's say for self-supporting products like tiles, there's greenstone, which is discarded glass, it's made out of discarded glass bottles. We can also use insulation products that are a resource from straw waste. Or there's this one that is made out of discarded glass. And last but not least, and I think this is my favorite of all, is to create intelligent systems. What if we can create systems that work rigorously to have multiple functions? What if landscape design is more than just an aesthetic feature? It can be a sewage treatment plant. This idea was developed by John Todd, who's a marine biologist and invented the living machine. He employs different plant life and organisms to naturally and organically treat industrial and municipal sewage. As waste passes from tank to tank, different plants will filter and digest the nutrients in the sewage through their roots. It starts off with quite primitive life forms such as blue algae, hyacinths, and other hardy plants that can survive harsh conditions. Progressively, they go through marshes composed of sand and gravel where more solids are removed. As the wastewater moves from one tank to another, the toxicity is reduced and an environment is created for more complex organisms to survive. You'll find tomatoes, eucalyptus, willow trees as part of this ecosystem, which leads me to state that architecture can be understood as a man-made ecosystem. And what if we were to take this sewage treatment plant and transform it into vertical farming elements? So as you become our future professionals, you will encounter great environmental challenges, but I hope you take these challenges as opportunities to innovate and advance our human existence. This is an illustration done by an artist named Rod Hunt, and he was commissioned to imagine and envision what a megacity in 2050 would look like, and what he sees is a future green city that does just that. He creates an ecosystem. With that in mind, I want to thank you for letting us share ideas, and I hope we have sparked your interest in climate action. Thank you so much.
Thank you, Lina, and so much. And Geoffrey?
Yes, ma'am.
You are on. It's a great segue.
Excellent. Yeah, it was, really couldn't have planned it any better. So are you guys able to see my screen?
Perfect. Thank you.
Excellent. All right. Well, again, you know, as everybody else has said, you know, I really appreciate you guys letting us kind of, you know, be a part of your morning. So I am going to talk to you a little bit about a project that I've been working on for the last little bit over a year. For Brookhaven National Laboratory, which is right in our own backyard, right? It's about 40 miles east of here out on Long Island. So BNL, for those of you who aren't familiar, is one of 17 United States Department of Energy funded national laboratories that are spread around the country. It's the closest one to New York City. And BNL has a number of different, you know, practice areas that they've sort of focused their research on. And a lot of them are focused around the environmental sciences, right? So sustainable energy, you know, sort of solving the energy challenges, Earth's ecosystems that Lena just brought up, sort of studying those things. They do a lot of battery research. So we very quickly kind of glommed onto that when they came to us for this new project. And, you know, the new building that they're creating, they came to us with a very simple objective, right? So it was provide, you know, between about 90 and 120,000 square feet of new space, not only for offices, but to serve as sort of a new welcome center and a new gateway to the lab. Right now, when people arrive at the lab, basically you check in for security and all of that stuff in a trailer. And I don't think that was the impression that they wanted to give off, sort of as a, you know, welcome to one of these 17 really important labs. So they knew that there were three things that they wanted inside the building, right? Visitor processing, which is what we just talked about, scientists coming in, students like yourselves coming in for a field trip, conferencing spaces, and then administrative space. Sorry about the mask. It slips down a lot when I talk, and we are required to wear them while we're in the office. And that was about all that they knew about what they wanted in this building. And they really left a lot of it up to us to help them define what the rest of the inside of this building wanted to be. So we held what we call a visioning session, right? This is how we kick off a lot of our projects where, and it depends on the project. We do different things based on the project. But, you know, in this instance, it was a lot about talking to stakeholders in the building, people that were going to be in the building, scientists from the rest of the lab, you know, about what they imagined this space could be, what their key sort of drivers were. And out of that comes, you know, a project mission, right? I'm sure you guys have heard of a mission statement, right? So, you know, Apple's mission statement is always to, you know, empower people to make great things. You know, so we come up with a mission for the project itself that we can use as a guidepost along the way to make sure that we're always sort of staying true to what we said we were seeking to do as a group. So for them, it was about reinventing the visitor experience through hospitality, convenience, and service, right? And telling the story of B&L, right? And the research that they're doing that's defining the future, and then also talking about the scientists who are actually conducting that research, right? They've had 7 Nobel Prize winners at Brookhaven National Lab. So really celebrating the people that make all of that happen. So we kind of came up with these 3 guideposts, right? It was about hospitality, right? So how do you make the experience a little bit better than arriving on campus and, you know, checking into kind of a cruddy guard booth and being told to go to a trailer to get your badge. About presence, right? So giving the lab sort of an identifiable beacon, the same way that the Empire State Building or the Statue of Liberty stands as this symbol for New York, right? Like, what could be the symbol for Brookhaven National Lab? And then about community, right? So really bridging the gap between, you know, the lab's campus itself and Long Island, and even, you know, greater New York City and the Northeast as a whole. So really helping to strengthen that connection. So I'll kind of blow through these really quickly. You know, if you look at their campus, so like I said, this is about 40 miles east of Manhattan, out on Long Island. It's in Brookhaven. And you can see this is really like the bulk of the campus. And you see like this big round thing. This is like a particle accelerator. There's actually another one of these that's off the top of the screen here that's about the same size as one of these dashed circles. It's like a mile across. And it's another one of these sort of proton accelerators. They do some really, really cool stuff out there. There's also this massive solar farm located just east of the campus, which is where they draw most of their power from. And then here you can see what we call the SUSC, and that's this project, right? So the Science and User Support Center. And then an area where they're currently, they house a lot of visiting scientists from other countries out here in the apartment area. So as we zoom in a little bit, you can see the main entrance to the campus is right here. And as you can tell right now, it's sort of an unceremonious entrance, right? So there's nothing that sort of says, hey, you've arrived. Like, you know, when you get to Disney World and you know, you see Cinderella's castle, there's nothing here that says that you've arrived at B&L. So that's what we wanted to help them create. So as we zoom in a little bit further, we'll talk about, you know, what we were handed and told, okay, this is the project site, right? This is the area that you have to work with. And then there's a whole other piece next to us, which on the last slide was labeled as the apartment area. That's actually going to become this whole, what's called a public-private partnership. And it's this whole development that's going to be almost like a Silicon Valley for science research. And they're hoping that that kind of gets built out over the next 10 to 20 years. So it's this really long-term project. But they wanted us as the designers to keep a really close eye on how these two things could interact with one another. So as you can see from the site, what was really interesting about it, what kind of struck us from day one as we started to think about where the building was going to sit, where parking would go, and things like that, was this was going to be a building that really had no backside, right? So a lot of buildings have the luxury of having a front and a back, and the back lets you hide a lot of the, you know, the cruddy stuff that makes a building able to eat and breathe and drink the way that we all do, and hide those things at a site. We didn't have that luxury. We really had 4 sort of fronts of the building, right? I mean, as people come onto the campus here from off the upper left part of the screen, they're going to get this view of whatever we put here head on. So you can kind of think of that at the front of the building, but at the same time, that's not where the entry needs to be. The entry needs to be down here off of where we knew that the parking had to go. So you've already got 2 fronts, and then you've got 2 very equally important, you know, views on either side. So I'm so glad that Lena brought up the things that she did about, using the sun, right, was one of the big concepts. And I think, what's been special about this project is, despite the fact that they're a Department of Energy funded lab, and they're really heavily focused on, sustainability and climate research, they don't have a ton of money to spend on this project. So it's a very tight budget. It's a government project. So we wanted to come up with some really clever strategies of how we could give the most sustainably responsible building possible without spending any extra money. Because the client told us from day one, if there's a single extra dollar to be had on this project, I'm going to use it to get more of my workers in the building. I'm not going to use it to put solar panels on the roof or to do wind turbines or any of these sort of, things that we tend to associate with being sustainable. So, Lena gave that really quick diagram about how you orient a building properly. So, as you all know, the sun rises in the east and sets in the west. It also behaves very differently in the summer than it does in the winter, right? In the summer, it gets much, much, much higher up in the sky than it does in the winter, and that's what leads to longer days, right? So it's got that much bigger arc to take. In the winter, the whole angle changes because of the way that we're orbiting around the sun. And I apologize if this is, very simple for you guys, but it's a concept that a lot of people don't understand. So in the winter, it's much, much, much lower, and that's what leads to shorter days. In the winter, you want to suck up as much of that sun as humanly possible because you want to help warm things up in a climate like New York. It's different if you're down in Florida, if you're working in Mexico. But here in New York, you want to absorb as much of that light and that heat as you can in the winter, and you want to shed as much of it as possible in the summer. And the worst of it is not actually at high noon, which I think is what everybody kind of intuitively expects. The worst ultraviolet energy from the sun actually occurs sort of late afternoon, right? It gets a little bit lower in the sky. The atmosphere is heated up all day. So it's usually 2:30, 3 o'clock, 4 o'clock when that sun is just able to kind of, it's a little bit lower and it's able to really stream into a building from the west side that just absolutely, it crushes the energy grid. And that's when, air conditioning usage is the highest. So that's what we always want to control for, is really trying to minimize that west-facing glazing as much as possible. And then the other thing about it is also glare and occupant comfort, right? So not just making sure that we're, controlling for how much heat is coming into the building, but making sure that, people aren't in a position where they want to put down the shades and all of a sudden now they're not getting to enjoy, natural daylight views, which we know is really important to people's health and well-being. So this shows a really poor way to orient a building, right? Again, in this climate in New York, it's a different story when you get elsewhere. This is the worst possible thing that we could do for a building, right? Face it southwest. The longest part of the building is absorbing the most heat, which means it's going to take the most energy and the most money to cool that building off. The best way to orient it is to put it like this, right? So the skinniest possible side is what's facing southwest, and you have this huge face facing southeast, right? So it's going to get really nice, warming sun in the winter, and it's going to only get the sunlight during the summer that it hasn't really warmed up too much yet. It's very high in the sky, so it's very easy to kind of keep it out of the building, right, and to shade things. And that was the other thing that Lena had talked about. So I'll try to speed this up a little bit. We always start off with some best practices that we teach our clients about, right? And that is, we talk about rectangular footprints being really easy to kind of plan and be efficient. And that goes back to Lena's other point about using less stuff. We talk about large footprints are good because the more people you can kind of get onto a single floor, right, which is a little bit counterintuitive. We think of New York, we think of high rises. That's just because land is so expensive and so hard to come by. But the more people you can get on a single floor, the more everybody gets to interact with one another, the more you get those sort of accidental collisions between people that really start to spark serendipity. And when that's not an option, that's when we start talking about, okay, well, what if we start cutting holes in the floors and stitching all of those floors back together? So our design concept for this building was really about taking those three things. If you remember way back early in the presentation, we talked about, visitor processing, conferencing, and office space, and looking at those three things as these three parts of the building and organizing them, understanding their relative sizes, and then combining them in some clever way, right? So we knew all of the stuff that we had just talked about the sun. We knew all those best practices about a rectilinear floor plate. We kind of want it to be narrow and long so people can get a lot of access to daylight and views. And now it becomes about actually creating the form of the building, right? So what happens if we take this thing and stick it on top of the other two pieces, right? Because we know all of these parts of the building want to interact and behave sort of very independently of one another. So you start to get this very natural way for the building to organize itself, and you can start making little moves that just give it that layer of design on top of sort of the intuitive nature of, well, of course this is how it should be, right? So, and then we just want to make one final move, right, which is to take the people that are in that big long bar up top in the office bar and see if we can't reconnect them to the site, right? So we sort of slope this thing down in the front, and we call this concept the bridge. And, you know, one other thing I want to point out is you'll see this very sort of nature-heavy imagery that we're using in this project. And that's because, you know, so aside from sort of being out in the middle of nowhere on Long Island, this project is in the Long Island Pine Barrens. And that's really sort of the most notable feature about the context of the project. So it's really famous for having, you know, these beautiful pine trees. And then, you know, when we thought about that, in the context of the kind of work that Brookhaven National Lab is famous for, right, all the climate research and sustainability stuff, it seemed very natural, no pun intended, to kind of, you know, paint this entire project with this, you know, sort of very earthy brush. So we came up with an entire site plan that was very, very largely based around all the things that Lena just talked about, right? Properly orienting a building, because it's the cheapest move you can make. It's free on day one to position the building in the right way. It doesn't cost anybody anything for us to put it this way, as opposed to rotating it the other way, but it'll end up saving half the construction cost in mechanicals and half the operating cost, because you're not forced to heat and cool a building that's stupidly laid out. So I'll kind of skip through all of this, but the gist of this is they really wanted this sort of campus feel. Eventually there will be 3 buildings that are part of this complex. So we gave them this great sort of like campus quad that's out front. And you'll see that coming up in some of the images. And then in terms of looking at other sustainable strategies that we could use, right? Big ones that are talked about a lot are daylighting, right? We know that people are happiest and most productive when they have access to daylight and views. There are options for mixed mode ventilation, which is very rare and very tough to do in a commercial office building, right? To actually have people be able to open windows. We talked about thermal masses, which is, you know, is there an opportunity to maybe, you know, have the roof of the building collect heat all day and then redistribute that heat throughout the evening to help kind of balance out the load. We talked about photovoltaic panels. Again, in the end, you know, as I mentioned, the client didn't have a lot of money. So a lot of these things that would have been additional expenses, you know, weren't going to make it into the final product. But I think the big one that we really focused on was daylighting, right? So once we had the building properly oriented, the next thing we did was to kind of decide, all right, where's the cores of the building going to be? And if you guys don't know what a core is, you know, it's where are the elevators, the stairs, the bathrooms, again, all those things that kind of help a building to eat and breathe and drink. Where are those things going to be relative to the workplace? So we just sort of started with the default position of, all right, let's test them out in the middle. And that's what you see here. And what these diagrams represent is what we call daylight autonomy, right? So that is the percentage of the day, let's say, that you could basically function in this building with no lights on, or the areas that you could function in the building with no lights on and just totally be supported by natural daylight. And you can see, you know, this is pretty good. If you look down here, about half the building doesn't need to have any lights on. But then the entire other half on the other side of the cores, you can see all of this blue. These are areas where we're not getting a lot of daylight autonomy. And then if you look at sun exposure, these areas very hot, right? So you're going to require a lot of cooling in them. People are going to have a lot of glare issues. So we said, well, what if we take all of those cores, all those solid objects in the building, and move them toward the south into that zone that is really starting to kind of say that it's less desirable. And what you can see is basically the entire north half of the floor plate, and this will make more sense once you see a floor plan, can basically function almost the entire year, almost the entire day with no artificial light required. So if you look at the floor plan, and this is the only one that I'm going to show, you'll notice that all of the stuff that we built, right, all of the solid objects that are going to be inside the building, we kind of built them in the south half of the building, right, in that zone where the daylight was too bright and too hot for people to sit there all day, but it's a great spot when you want to get up and get some sunshine and you just need to pass through a zone really quickly. It's a great spot to have people go on a really interim short-term basis. And again, if you look at sort of the section of the building as it's been developed, it gets taller towards the north, right? We want to let in as much daylight as possible. There's no penalty associated with that daylight because it's not hot at that point, right? It's just north diffuse light. And then we kind of close down as you get towards the south side of the building to control the glazing. And then the last thing that I'll call out on these is these big fins. We're actually using the mullions that hold up the curtain wall of the building, right? Support all the glass. We ordered them extra deep, essentially over a foot deep, and they're going to provide all of the shading that we need for the building. So not only are they supporting the glass, they're also shading the glass at the same time without having to buy anything extra to achieve that. So just looking at some aerial views of where we are right now in the project, we're a few months away from issuing the final documentation, and then eventually they'll kind of get into the ground and start building this thing, which we're really excited about. So again, sort of this really earthy palette, really natural, right? So it's a precast concrete down here, but we did what's called a board forming on it. So it actually ends up sort of looking like wood, right? As a nod back to the fact that this thing is in the Pine Barrens. And then it's all just a pre-weathered steel up top, sort of very machined. It looks very scientific, very tectonic, if you will. And then inside, it's exactly what Lena said. Use less stuff where you can. And again, this was a building where we just wanted to be really honest about what it was. So we're leaving all of the steel exposed, all of the ceilings exposed. Again, really heavy use of wood. But you can see it's a very narrow building, so everybody's always really close to glass. And then again, the south is off to the right side. You can see here's, all the really bright sunlight coming in, and these are sort of the more transient spaces in the building, right? So this is where I go just really quickly to grab a coffee, grab a drink, take the stairs, but all of the work happens in the north half where I'll never have to put down the shades. I'll never have to worry about being too hot in the middle of the day because the sun is beating down on me. And these are sort of the beautiful, like, double height workspaces that you're going to get inside of the building. So we are super excited. And I thank you guys for letting me drone on for 20 minutes, and I will hand it back over to Anne-Sophie.
Thank you, Geoffrey. That was perfect. Great timekeeping and such a great project. It's also, I had never seen the interior shot, so that's really good to see as well. I'm going to pass it on very quickly to Tom and to Anna. And Anna, we have not met in person, but I can't thank you enough for joining us today. Over to you.
All right. So can you guys hear me?
Yes, sir.
Okay, cool. So let me go ahead and bring up our presentation. You guys see it? Oops. Let's start from the beginning. Can you guys see my screen?
Not yet.
No.
No. Okay, hang on. Okay, here we go. All right.
It's loading. Yep. Oop.
There we go. Okay, so yeah, my name is Tom Brock. I'm a project architect at Gensler, and like we said, we're super thrilled to have Anna here from our client Delos to sort of help me flesh out some of these concepts and talk about the project a bit. So back about 3 years ago, 2017, we had the opportunity to work with them, to collaborate with them really on really interesting and challenging sort of project they brought to us to do a new headquarters for them in a new tower going up in the meatpacking district here in Manhattan. So yeah, without further ado, sort of let's get into sort of what they do and then how we were able to work with them. So client focus first on Delos. So for me, sort of when I try to synthesize who they are, I'm thinking wellness intelligence. And so from sort of their own mission statement, they're really talking about enhancing health and wellness of the people using sort of the built environment. and sort of bringing that to sort of the forefront in terms of how we're thinking about the built space. And basically the story was about, I think in 2014, or a little bit earlier it must have been, it was two brothers who were coming from the finance world, and they sort of noticed a hole in the real estate market. So everyone was talking about LEED, but LEED was more focused on sort of energy consumption and sort of material strategies, whereas no one was really talking a whole lot about the actual people using the space and sort of their needs from a wellness perspective. So they sought to come up with a complementary building standard that would sort of bring together the building science side, which would be more LEED, with the health sciences. And again, to sort of bring that sort of into the core. And so basically these health strategies would be not so much just like a nice to have add-on, but really sort of a focus for projects moving forward. And that actually, in the world of COVID now, is even more important. So thinking about the why, so over time, our bodies have adapted to the world around us. Examples would be sort of the light cycle. So, you know, when the sun comes up, we feel more awake and able to energize for the day. And then as the sun starts setting, we start, our systems sort of start calming down. Our bodies are tuned to want sort of clean air, clean water, free from pollutants. But as we've sort of modernized and things have changed around us, people are exercising less, we're eating less like healthy foods. The pollution around us from cars, from the chemicals in our fabrics, just everything, and overall spending less time outdoors. And that fact alone makes sort of how we're building our built environments, since we're spending so much time in them, that makes it ever more important. So as we can kind of see as a result, we're thinking about increased health concerns, overall just stress, social isolation, loneliness. So in a sense, what the two brothers that created Delos were seeking to create was a way to sort of measure, monitor, and then ultimately certify buildings as sort of having met these new criteria for a healthy environment to live and work in. So I don't know, Anna, if you want to sort of jump in and add anything to that, but we'll jump into sort of the what is WELL certification, but I don't know if there was anything that we touched on here that you'd like to add to.
No, Tom, I think you pretty much covered it, at least in broad strokes. And I just wanted to reiterate that some of the fundamental concerns that the WELL building standard addresses is the consequence of spending so much of our time indoors. If we think about it, over 90% of our time is spent somewhere indoors, and at school, at work, in public transportation, in shops, and when we have a chance to return to them, places of recreation. And the idea is definitely not new to architects to think about how does being inside impact the person's and the human experience in it. However, what the WELL building standard really did is capture that in a systematic, evidence-based, peer-reviewed way, combined with performance verification. So every strategy within the WELL building standard is not only grounded in scientific research and validated, but also at the end of the project is verified with lab testing and sample collection and kind of environmental analysis that seeks to confirm that all of the initiatives and all of the effort that went into design and planning actually manifested itself in the way it was designed. So I think when you see the photographs from the space and some of the really cool and distinctive details, such as our data screen and something that we work with Gensler specifically, you'll get a sense of what it's like to really turn a focus to some of these invisible aspects of the design and that still have a huge, tremendous impact on how it feels to be in the space and what it means to be in a WELL certified space. I think, first of all, thank you very much for inviting me to give this occupant and client perspective, as someone who has had the pleasure to work out of the office up until the pandemic took us all home about almost a year ago, I think one of the most poignant things that people shared and our colleagues all noticed is that when we spend a whole day in the office and you step outside at the end of the day, you don't have that feeling that like, oh, I just spent like 9 hours inside and now I can finally breathe easy. The design from the materials and kind of the organizational aspect, but also from the mechanical standpoint, from the air ventilation and filtration point of view, contributes so impactfully to the feeling of being inside that we never have that feeling of exhaustion that comes from being in a built environment. And that's ultimately really a testament to how successful the design, the collaboration between Delos and Gensler was in this project, and the strength of the well building certification here. But Tom, I'll let you get through the presentation because I know you have a number of really wonderful images to share.
Yeah, and I want to be respectful of your time because I know you have to jump in not too long. So we'll try to just touch high level on sort of what is WELL certification, what is the WELL standard. So as we were sort of talking about, WELL was intended to sort of work in concert with LEED to sort of bring the user health and wellness into the building health and wellness sort of as one. So it basically created a way to sort of measure those metrics, and Anna sort of touched on sort of how those things get measured at the very end, but also sort of along the way as we're looking at what's actually being put into the project. So there's sort of 7 different categories that make up a WELL person, I would say. So it's the air around you, the water you're taking in, the food, the healthy food that you're bringing into your body, the light in the space around you, whether it be natural or we'll kind of look at some other strategies for when natural light's not possible. Fitness, like movement, overall comfort, be that whether you're warm or cold or sort of just like feeling at ease, and also that ties into the mind as well. So we'll look at some different ways in which the mind is nurtured. And yeah, WELL is sort of one of a constellation of different strategies and standards that popped up in probably the last 20 years or so. And the thing that makes it pretty distinct is that it's 100% focused on the health and wellness of the occupant, whereas LEED, as you can see, is maybe only 28% on the person. LBC, which is another one that this project was looking at, is I would say focused on sort of the health of the materials actually being brought in, making sure you're not bringing anything toxic like lead. So we actually sought to use these 3 for the project and try to reach their highest levels of certification, and that in itself was a little challenging. So we won't delve into that too much today, but in an overall context, this I had to update because it's been rapidly growing ever since this slide was first created. So we've got almost 1 billion square feet of space in 67 countries. In terms of Gensler itself, I think this number has probably grown, but these are some projects that we've been able to achieve a WELL certification. And Delos, I would say, is probably one of our favorites to talk about and be proud of. An easy way to think about WELL is like it's a nutrition label. So there's a scorecard in essence that's going to show you kind of how you scored in different areas. So then you can kind of judge on a pretty standardized way in terms of how well your building is working for the people that are actually occupying. So something that sort of makes this a little different from LEED also is that it's about half related to the actual programs and policies of the users, the managers of the space, whereas architecture, sort of what goes into the building in terms of materials and layout and design, is about a quarter. Engineering, sort of the plumbing, the heat and cooling, the air filtration is another quarter. But really, like, it's really on the users themselves also to have these sort of guidelines in place to really enhance that wellness. And so these all kind of work together, and these are just some examples of sort of tactics from each of these little zones. So there's overlap with LEED in terms of some of these things like no smoking, reducing air pollutants, having a thermally comfortable space in terms of heating and cooling, architecture, again, those kind of things. This part about the vestibule is really sort of how we're mitigating going from the outside to the inside, controlling sort of what goes in and out, keeping things clean. MEP has sort of more of the engineered focus on things like the ventilation, and acoustics is actually another one that you may not think about, but if a space is too loud, it can really affect how comfortable you are in the space. Like if you've got noises bouncing around you, it's very distracting, like you don't want to be there. So this is actually a construction photo I dug out of my phone. So this was an all concrete structure, and this is actually in the cafe space we'll look at later, but we had this kind of sprayed sound absorbing material that went on the top slab here that helped to kind of mask some of these conduits and stuff for the lighting, but also really helps to make a more sound comfortable space for them. Lighting was another big tactic we'll look at, and sort of how it either sort of energizes you or helps you calm down at the end of the day. And sort of having comfortable lighting means no glare on when you're looking up at the light fixture, so you have a lens, as we're talking about here, but also in terms of the color of the lighting. So you may notice if you're in like a Best Buy, the light's very bright and of a certain color, whereas if you're more at home, you'll notice that the lights in your lamps are maybe a little bit different. So that's very important to sort of what you're doing and how you're feeling. And like we said, operations are really like 50% of the credits we're looking at for well, and really sort of having these guidelines in place for the continued use of the space once the architect and the engineer leave. So the process itself will kind of be this pretty basic, but basically the whole design team has to get on board at the very beginning of the project and sort of have the end goal of certification in mind, because any slip-ups in one area, be that the contractor lets people bring in the wrong materials to build the walls or whatever, like the engineers have to be using the correct sort of the air controllers. We had to get a specialized lighting team on board. All that goes into putting together our documents that, we're basically checking to make sure we're meeting all the criteria. And then as the contractor is sort of sending us approvals for things, we're checking to make sure that all the materials look correct. We're not bringing anything bad in. It gets all built, and then as Anna touched on, once they've occupied the space for 6 months or so, they can actually look at the metrics that are coming out of the air quality, things like that, submit all the data in one big package, and then get certified. And actually, we're approaching the 3-year mark, so Anna and her team will be sort of going through the recertification process, and so that should be interesting, and I'm sure I'll hear a little bit about that, hopefully. That would be good. I have a video to show, but it's a little bit, I'm gonna have to jump to, I wasn't able to get it to actually go into my presentation, unfortunately, but here we go. So that's the
Tom, if I can provide some little voiceover here, unsolicited, of course, but just a little bit of background of what you guys are seeing on the screen. So especially some of the data screen that you saw earlier, and I think, yeah, this one. This is something that we're super excited about, really proud to showcase in the lobby of our space. And this is a really, truly a result of a deep collaboration between Delos and Gensler. there are in the well building standards certain requirements about monitoring indoor environmental quality. So, you know, it says measure air, measure water, measure acoustics, measure lighting. But there's really no requirement on how exactly it could be measured. Now for Delos, this is really a tremendously important part, and possibly the most important part of the whole enterprise, which is to understand and really visualize, manifest, like be open about it, broadcast, and be proud of how the space performs. So this giant screen that really takes a dominant position, it's probably our largest piece of digital art in the office, is really a testament to how proud we are of our space and how excited we are to share some of these details and really show how beautiful they can be. The background of the screen is blue, and you wouldn't think anything of it, but it actually, the tint of blue and the intensity and the color hue shifts gradually throughout the day to reflect the circadian changes of the outdoor lighting, something that we spoke in earlier in the hour. And that's really just like these kind of details really make that space special. And the screen is really kind of a one-stop visual to sum it all up. And whenever we host tours, or when we did host other people in our office before COVID, we would certainly use this this landing in our lobby as kind of the main starting point, and also one where we would end up as well, because it all comes down to data, it all comes down to science, and it all comes down to celebrating and manifesting some of these really critical aspects of the built environment that often go and ignored after the design is complete.
Cool. That was a great synopsis.
Hi, my name is Makai. First off, I want to say thank you for everyone's presentations. I feel like I can speak for everyone when we say we really enjoyed it. And I'm sorry to interrupt you, but we all have questions, and for time's sake, being that our next period will be starting soon,
yeah,
we feel it would be the most appropriate time for us to start asking questions.
Sure. Let me just, as you're asking, I can sort of click through some images from the project that may inspire some more questions. There's some text on the screen if you want to be reading it while people are asking questions, but I wanted you guys to be able to see a little bit more other than the video. So
yes, that would be great. Thank you.
Okay. So without any hesitation, please go ahead with your questions.
Okay, so I have a spreadsheet where other students ask questions. So I'll start reading some of the questions to kind of speed up the process. But if I ask the students if they can start raising their hands now, so their names could be called, and I'll call them one by one. So one of the first questions I have is from Gilbert Bueno for Tom Brock. He asks, what are some of your adaptive reuse projects, and how did you go about concept design?
You said adaptive readings?
No.
Reuse. Adaptive reuse. Okay.
Yeah.
So the adaptive reuse, that was when I was in Washington, D.C. And a couple of those, I guess one that's sort of jumping out to me right now is just south of Capitol Hill, there was an old hospital for people in the Navy during the Civil War. And it sort of became run down over time. And the local community, with I think public funding, decided to sort of change the use of that from just basically an abandoned building into a community center. So it was a really beautiful sort of large stately building, and we were able to, high ceilings, beautiful detailing. So there was a lot of wanting to preserve as much as we could while also bringing sort of modern content. So we kept sort of the high ceilings, the moldings, the wood flooring, the staircases and things like that. But we were able to bring, for instance, a TV studio into the basement, which had previously been used for like horses and stuff. So that was pretty interesting. And the process for that, it was really just meeting with the stakeholders in the project. So there was a sort of a community group that had raised funds for the build out. And they had sort of dreams about the different kinds of program that could be held. So whether that's classes, or if you wanted to film a cooking show, like basically any eventuality, typically I would say around sort of creative pursuits and things like that. And it sort of became a neighborhood hub for that sort of Capitol Hill area. So it's one I'm really proud of. That was actually almost 10 years ago, which makes me feel really old, but that's really a beautiful project. And if you want to look it up, I don't have any images, unfortunately, with me right now, but it's Old Naval Hospital in DC. Hopefully that answered your question.
Yes, thank you. The next question that I see is from Saba Shugvani. He asked, Aunt Sophie, can you talk about your more than 20 years of experience?
Oh my goodness, this is quite...
Wow.
You're on mute, Aunt Sophie.
Oh, am I? Oh,
she
okay.
ran away.
Yeah,
She didn't want to talk about it.
yeah, exactly. Maybe I shouldn't even talk about it, because 20 years in 2 minutes, that's almost impossible. But what I will say is that, you know, looking back, I guess I'm not surprised about the, you know, kind of my kind of, you know, the parcours, if you will, of my career. However, you know, when I was you know, when I look at it, you know, I worked for a very small firm. I worked, you know, and I've always worked in, you know, on projects that were really about architecture and more than interiors. But you know, when I look back, it makes complete sense, in the sense that every single, you know, place I've worked at or projects I've worked on, each time have taught me a lot. And so while, you know, what I would say for the students is that, you know, while you are in a certain situation, and, you know, for me, for example, when my first job was here in this country, and I was graduating from France, and, you know, I basically took what I could take, right? I did not have the luxury of, you know, coming from an architectural degree here in this country, and so on and so forth. But I will say that, you know, when I was in that position, I was able to bring the best of, you know, what I wanted to do, and use the, you know, everything I had learned prior, and make the best of it. So every time, I think it was about having an attitude of, you know, kind of being open to learning, and being open to learning from others, and questioning, you know, what you're doing and what others are doing, and being curious. So while, you know, it's never perfect, I will say that I have zero regrets, and I've enjoyed everything I've done, and it was all needed. You know, everything I've done was really needed to lead me to where I am. So I think that's, in a nutshell, what I would say. And, you know, I've worked on very small projects, on very large projects, on, you know, kind of repositioning projects, so meaning, you know, the reuse of an existing project into something else, and or on completely, you know, ground up new projects. And, you know, again, all of these experiences have been very complementary, and I've, at the end, make me a better, you know, a better professional. And I really hope it's not, you know, the end of learning. So I'm looking forward to the next 20 years. But I'm happy to answer more detailed questions, of course, at any point outside of this. I don't want to take everybody's time.
Thank you so much. I see Brandon Rosario has his hand raised. So Brandon, if you could do me the favor and ask your question.
All right. Hello, my name is Brandon, and my question is, during the first presentation, a very interesting point was made that one idea to decrease pollution in construction was lessening the amount of vehicles, and to make, you know, less buildings made for no reason. And my question is, would these ideas increase or decrease construction speeds?
To like the actual building schedule, you mean?
Yes, in terms of times, and with the decreased amount of vehicles that would be used, how would that affect construction?
Well, that's a good question. I think if we build less and provide more, that means we demand less materials. We have a smaller footprint, and therefore construction, the timeline of construction would be less onerous and hopefully less time. And I think with technology, I think we're advancing to become more efficient. That's another layer added to it. We're becoming more efficient with the way buildings are constructed. As far as cars, if we concentrate our built environment within cities, we therefore have less reliance on cars and instead opt for walking or biking to and from your destination. So that in itself helps with carbon emissions, right? So everything has a, smart decisions and good ethical decisions has a knock-on effect that produces a positive outcome. Does that make sense?
Yes, thank you.
Great.
Okay, one more question is from Nigel John for Lena Ayala. He asked, how was your experience in working on large projects in the Middle East?
Well, that is very interesting, and it was a big learning lesson for us at Gensler and for me especially, because it just showed this was prior to the 2008 economic crisis, the real estate boom once it crashed. And so prior to that, I think many clients were very eager to build and overbuild, and sometimes based on speculation when really there wasn't demand. So that goes against the principles that we just presented today, to build as necessary and build on locations already in place. And projects in the UAE created were based on vast lands that have been untouched.
And Lena, they were also, at that time, they were actually using a lot of resources to construct like islands off of Dubai and things like that. So there was a lot of excess and a lot of damage being done. But yeah, go ahead.
No, yes, exactly. And so in that process, just as Tom mentioned, a lot of material was used, a lot of energy was used unnecessarily. And in the end, with the economic recession, a lot of these projects were put on hold midway through construction. And it wasn't just Gensler that was impacted by this, but all of the architecture and construction industry. So I think we need to take that as a big lesson for us and learn from it and say that we can do better, be more frugal and be smarter and intelligent in the way we create the built environment.
Thank you.